Hi, we're here with Max Hinson from Green Hills Software. Max is going to talk to us a little bit about security and the Internet of Things. Max, you're going to talk to us about something that's near and dear to the hearts of many of us, credit card fraud. How do you secure against credit card fraud when you're talking about the cloud and the Internet?
Exactly. So for security, you really need to take a holistic approach. And so what we're doing here is we're using our Integrity real-time operating system to secure the devices themselves. Now, what we've seen in the last few months is that companies like Target, Home Depot, and others have been hacked. And what hackers are going after is not the servers, sometimes they do, but what we're seeing more of now is they're attacking the devices themselves. And so that creates a lot of entry points for hackers to get at these devices, since they're now connected to the internet. So a typical payment system looks like this. We've got a point of sale terminal, and each terminal has some hardware. It's running some kind of payment client. Now the problem is that a lot of these systems are running embedded Linux or some other kind of operating system that has known vulnerabilities. Now, hackers are out there and they want to get into these devices to steal credit card information. Hackers have multiple attack vectors. They can get in with physical access to the hardware, they can get in through the internet, and so what they want to do ultimately is place malware on these devices. In the case of Target and Home Depot, what we've seen is that this malware gets on these devices and it's able to look through the RAM that's storing this sensitive credit card data. Now, the credit card payment industry does have standards for security called PCI DSS, and it says that any information that's sent over the internet must be encrypted. Also, any information that's stored on a hard drive must be encrypted. But there's this point in between where credit card data is being processed in RAM where it's not secured. And that's exactly where this malware is striking. So when you swipe your credit card data is processed by the payment client, it goes through RAM, and then is eventually transmitted over the internet. In that brief instant when it's in RAM, the malware is reading through RAM, it's able to find the credit card's easily identifiable signature. Once it finds it, the malware processes it and sends it right back up over the internet to the hacker. Now, the scary thing is that your payment will still go through. You'll be able to purchase the items that you were hoping to purchase, and if you didn't know any better, then you would have no idea that hackers now have your information. So we'll demonstrate that here with this payment terminal. Now, when we swipe our credit card, we'll see that immediately the hacker's malware that's been installed on the device has read the credit card data. It finds that easily identifiable signature, and it now has your name, your credit card number, your expiration date, and any other data that was on that magnetic stripe on the credit card. Now, this is before we've even entered our zip code and completed the payment. So we can type in our zip code, complete the payment server has received it, and you've now purchased your goods. Now, this is really, really bad. We do not want this to happen, so this is where Integrity comes in. Integrity is a real-time operating system that was built with security in mind from the ground up. And what we do is we use Integrity's virtualization properties to strip out the security critical components from the components that are vulnerable. So we take the device drivers that run the magnetic stripe reader as well as the pin pad, and we strip them away from embedded Linux that runs graphics as well as internet connectivity. And this allows us to be able to swipe our card. It's being processed in a secure environment on Integrity. All that Linux ever sees is a token, so it does not see the raw credit card data. And then your payment is processed securely using SSL and other network encryption methods on the network side.
Okay. Max, for our listeners who may not know what a token is, can you just go through that?
A token is really just a one-time use string. And so what it allows us to do is to be able to randomly generate a sequence of characters known as a token so that we can use it once just to complete a payment, and any hacker that has this token is not able to replay the payment and charge you for more than you actually paid for.
Yeah. Awesome.
So now that we've secured our device with integrity, we can move over to our secured terminal, swipe our credit card, and now we can see that the malware that's been installed on this system is still scanning memory, but it will never be able to find it because it's in a virtual address space.
So you can prevent the malware from doing what it's trying to do, but you can't prevent the malware from being downloaded.
Well, it depends on how you architect your system. If you want to keep embedded Linux in the mix, which a lot of application developers do, you can still do that. But what we provide is this virtualization so that you can separate out security critical components from ones that are vulnerable.
Does it matter what hardware platform you're using?
Integrity is pretty hardware agnostic. We run on a lot of different chips. In this case, we're running on Freescale's IMX6 platform.
Well, Max, I feel better about putting my credit card through a credit card reader now. Thank you for that.
Thank you.